All right. Somebody indicate they can hear me and see the screen.
I can hear you and see the screen.
Okay. That will. I'll start with the week announcements. Okay. This is week 3. We're going to try to cover blood vessels in the lab, which I was going to try to show you. But in the lab, we have 2 assignments. We have blood vessel activity 1, Physio X, and the instructions for that are underneath the lab module. Okay, you will actually go to Pearson to do that. It's not a homework assignment, it's a lab assignment. The only homework assignment is a chapter test for chapter 19. There is no additional assignments. So under Pearson assignments, you only have the 1 assignment for next week. And then I wrote that it was where it was. What's due today was the chapter 17 blood module, the Pearson assignments for chapter 18, and the student contract, which is for 1 point extra credit. What's due for our next Thursday is chapter 18, the heart module, okay, which we went over, okay, and it was 1, filling out a diagram after you'd watched 3 videos, and the other was to watch some interactive videos and watch some animated videos and fill in the blanks, okay. And then on the discussion board, it's on the discussion board where you fill in your introduction, okay. You don't turn it in as an assignment under introduction, you fill it in under the discussion board, okay? That's where you put your assignment. And then I go to the discussion board with a class roster and write down everybody that did it and award everybody 2 points that did the introduction. Do not be skimpy on the introduction, okay? Somebody wrote maybe two sentences, maybe 3 sentences in the first paragraph. The second paragraph was 1 sentence, okay? I'm not going to give you 2 points for that, okay? Yeah, these are 2 paragraphs. You can say something more than, I'm at FSCJ to learn nursing, okay? You got to say a little bit more than that. If you want the extra points, if you don't, I won't give them to you, okay? It's a way of introducing yourself. You don't, at least 2 or 3 sentences in each paragraph. I mean, 1 sentence a paragraph is not very much, okay? And then a Pearson assignments for chapter 19. And then finally, on March 4th, we have the chapter 19 blood module, lab module, which is the one that opens up today. One of them deals with what happens to blood flow when you increase the radius, and what happens to blood flow when you increase the vessel length. Okay, those are the 2 activities that you're going to do. Remember, instead of just answering the questions, you had to click and turn in a full report. Otherwise, I don't care what the Pearsons assigned you. If you don't turn in a full report, you don't turn in a full lab report, you're not going to get the full credit for it. Okay, you're not going to get the full credit for it. And what I decided to do with that chapter 17 on Pearson is you just have to answer, if you've already done the chapter 17 on Pearson assignments, then the Pearson lab, you just have to answer those 4 questions, and that's the easiest 15 points you'll ever get, answering 4 questions, okay? That's the easiest 15 points you'll ever get, answering 4 questions. So just go ahead and answer the 4 questions. It gives you multiple opportunities to answer the questions. I want to go back here to modules, okay? And go to our calendar activities. If you haven't noticed yet, okay? We're finishing up the first module. Remember, the first module has has blood, has the medium, has the pump, okay? Heart, chapter 18, and then blood vessels are the highways, chapter 19. So we're going to have an exam, and the exam is going to open next Thursday at 6 o'clock, okay? And it will close 1 week later at 6 o'clock. You have one opportunity to take the exam. The exam is located under assignments, okay? We will have an exam review next week, starting promptly at 6 o'clock. It will probably go from 6 to 6:30. It will not be taped. There will be no recording of it. If you're not here for the review, you don't get the review. If you're not here at 6 o'clock, you won't hear the review. The exam consists of 125 points. multiple choice, matching, true, false, and short answer. 55 points, 55 points of that 125 points, 55 points of the 125 points is short answer. Essentially, we're going to work through the short answer questions, and in the process of doing that, we will review the material. We will work through the short answer questions, which is what I did with the other class. And you can obviously, there is no doubt in your mind, I'm grading their exams. They just finished up their exams on Tuesday. There's no doubt in your mind who attended the review and who didn't attend the review. Because if you didn't attend the review, you're probably, you probably don't know even what the question's answering, even though the question, or what the question asks, even though the question comes directly from the notes and from the slides. And if you had me last semester, I have added this one requirement that when you answer a short answer question, you have to tell me where you took the answer from. You can either say notes, you can say slides, you can say lecture, you can say textbook, you can say Pearson assignments, but you have to tell me someplace, because some of the answers I got last time on Anatomy and Physiology 1 came directly from the internet. I'm not going to tolerate it this time. Okay. Those are your sources. And like I say, if you haven't listened to the lectures, you're missing out, because there's a lot of information that I give in addition to the notes and in addition to the slides in the lectures for which you are responsible for. The notes will get you a 70. The notes and slides will probably get you an 80. Okay. But unless you actually either attend the lectures or listen to the lectures, okay, attend the lectures or listen to the lectures. And it doesn't matter if it's this lecture or the lecture from last semester or the lecture from 2 semesters ago. I've been teaching this 5 years. I emphasize the same points every time. I can tell you in this chapter, the big ticket item is what happens in the capillaries. What happens in the capillaries. And when we get to there, we'll go over it ad nauseum, okay? And that'll be one of the things we'll go over ad nauseum in the review, okay? What happens on the arterial end and the venous end in regards to hydrostatic pressure and oncotic pressure. And what's the net? Is it net out? Is it net in? Okay. Does all the fluid that comes out go back into the vessels? Does it stay out? And so you really, well, it's just entirely up to you. You can come to review next week at 6 o'clock. We'll review from about 6 to 6:30, and then we'll start on lymphatic and immune system, or not. It will not be recorded. It will not be recorded. The only part that will be recorded will be the lecture. The review is not recorded. So you're either here or you're not. So my suggestion to you would be you be here for the review. Get you a pencil and paper. Take notes. Listen to what I have to say, because you're going to see these questions again and these concepts again when you get to the short answer. So that's all I've got to say about that. So the exam will open up next Thursday. You have 1 week to complete it. It's a 2-hour exam. Once you press start, you got 2 hours to complete it. It doesn't matter if you log off, if you unplug your computer and you shut your power off at the house. The timer on the exam starts when you open up the exam, when you press start, and in 2 hours it will submit it. And if you mess up, then you're going to force yourself to have to take a written test, which will be short answer and short essay at the end of the semester on these particular topics. So you don't want to do that. You want to take the exam. I said you can miss one exam, but you have to contact me before the exam's over. If you miss the exam, you have to contact me before the exam's over if you miss the exam, and you have to give me a reason for missing the exam. And you'll still make it up at the end of the semester. If you've looked at the schedule, it's not something you want to be doing, making up at the end of the semester. I don't go to the campus. I don't drop exams off in the assessment center for you to come and take, because that means I got to drive back out there and pick up the exam. So I'll say a whole lot. Part of the review is saying a whole lot more in detail about the exam. Okay. But you have to understand that if you decide that you're going to take the short answer questions and go to the internet and copy stuff off of there verbatim or paraphrase it, I'll just stick it into our into our plagiarism software called Turnitin. If it pops out that you plagiarize it, you get a 0. You get 2 pops out, you get 0. Okay. You get 3 pops out, you get reported to whoever reports you to, the ethics committee or whoever. So you don't want to do that. Okay. You want to show up. You want to show up for the review next week at 6 o'clock, and you'll have a good idea what's going to be on those short answer questions. Okay. And don't anybody ask me how many questions they are. Okay. On the exam. I really don't care. Okay. Some of them are multiple choice, some of them are matching. So it might have 5 parts in that matching question, and each one of the parts might count 2 points. So it's essentially that's 5 questions, but on the thing, it would only list it as 1 question. So it really, that's not a concept. You have plenty of time while most people finish the exam way ahead of time. Okay. So that's all we're going to say about the exam. And let's see, modules here. So here's our module here. The blood vessels, you can see there's already a recorded lecture there. That's probably, I don't know when it is from, but it's probably from the summer. It's probably, yeah, it's probably from the summer or fall. Okay. And then here's the student notes, and here's the slides. Right here is the instructions for doing the blood vessel lab. And since we started the labs new, I had to rewrite these instructions, but these tells you exactly what to do on the instructions and gives you an example of what happens if you turn in late. And I don't know why this keeps coming up, because I paid for another year of Office Suite, but it does, and I'm not going to worry about it because it's paid.
Professor, can you hear me?
I can hear you, yes.
Before we go too much further, I have a question.
Yes.
My Pearson has been messing up for the past like 2 or 3 days, and I kept waiting because I thought it was something on Pearson's side. But I was wondering if you had the problem too, because I logged in to do my homework and I wasn't able to get to the course home. I was able to get to everything else except for the course home. I don't know what's wrong with it.
Did you contact Pearson, ask the customer service?
I did not. I thought it was something they might have been getting their website updated or something, but I can share
well, you saw, I actually just tried to go to Pearson. Okay. I actually just tried to, but I was in Pearson a while ago looking to see who had registered, because I have to turn in actually I'm one day past the deadline for turning in for people that's going to be dropped because they didn't sign up or they didn't participate in class. And I only got one person that hadn't participated, didn't sign up for Pearson and wasn't participating. So I had to turn in something for that person. But otherwise, everybody else signed up for Pearson. But just a minute ago, I tried going, but I was on Pearson about 5 o'clock looking to see who had signed up with the class roster to check who had signed up. So I haven't had any problem getting there.
Yes, sir. I was just wondering if I'd be able to I was wondering if I could turn in my work tomorrow, maybe if it started working tomorrow. I didn't know if you'd count off for that stuff.
Well, I don't count off Art Pearson counts. You've been 3 days and it's not working. You hadn't contacted customer service.
I thought it was something they were updating their website, or maybe their server shut down. So I didn't know what to do. I'm sorry.
Okay, well that's all right.
I done my work from the first week. I didn't know what was up with it.
I'm very lenient on getting late work in. You'll see later on, because this is a 12-week class, but and so if that's the only thing that happens to you, just make sure you send me an email that you did it so I can look at it. Okay. And make sure you didn't get any deduction. All right. Did you hear what I said? Did you hear me? So just go
my
ahead. My
computer's acting up. Sorry.
Yeah.
But thank you.
If you can't get to Pearson, go ahead and contact them and say, hey, I can't get to Pearson. Dr. Phelps can get to Pearson, but I can't get to Pearson. And see what's going on and have them to help you, because I don't have anything to do with the back end. I can't even add students. Okay. You have to add yourself. I can't even add students. All I can do is set up the class. That's literally all I can do is set up the class. One time I messed up the number, but that was a long time ago. I don't know, 2 or 3 years ago, and I had to drop that class and set up another class and notify Pearson that I messed up. But otherwise, that's literally all I do is set up the class and then add the assignments, because the assignments are already there. So if you have any kind of problem logging into Pearson, you had to contact them. I had a problem first of this semester, and I had to contact them. It took them 24 hours to fix it. Okay, it took them 24 hours, and that was with the Adobe Flash Player. And they gave me access, but I went straight in access, and I didn't have to do all those instructions. Well, that doesn't do any good because that you don't have the straight in access. So that's why I went to Pearson. So just go ahead and do it. When you get them done, notify me that you had a problem with Pearson and notify me what you got done and what you turned in late, and I'll take care of it. Okay?
Yes, sir. I just want to make sure that was cool with you.
Well, don't say it's cool with me. Okay?
I'm sorry. I want to make sure you're okay with that.
I grew up in the 60s. Okay. I was in college in the 60s. Okay. So you probably could say it's cool and groovy, and that'd be okay. Just to tell you the truth.
Yes, sir. I'm in high school, so that's how we all talk. I'm sorry.
Well, I'm sorry about that. I graduated high school in 1968. Okay. West Fannin High School in Blue Ridge, Georgia, in the middle of nowhere, USA. You spent your life you spent your years trying to get out of there, and now you try to go back every year for a week vacation because it's up in the mountains. We're going to talk about blood vessels. Always you can email. Always email. I'm very responsive to email. Okay. I may seem like a grumpy old guy, and my wife will tell you, who I've been married to for 45 years, I'm a grumpy old guy. But you can all send me an email, and I'll probably ask you, when you send me an email, you'll say I'm behind, and I'll say, what are you behind in? Okay. Don't forget. Oh, last thing. Do not forget now that I've got 2 classes. So in the subject area, either put Monday or Thursday. Okay. You don't have to put you don't have to put course number. You don't have to put anything else. Just put Monday or Thursday. Okay. That tells me which class you're in, because they're both anatomy and physiology 2 classes. And so if you just put Monday or Thursday, that tells me if you're in the 15-week class or the 12-week class. So blood vessels, we're going to talk a little bit about blood vessels. There's 5 basic types. Okay, you already know this. Okay, they're arteries which carry blood away from the heart, except for, well, actually the pulmonary artery, the pulmonary trunk carries blood away from the heart. Okay, there are arterioles. Okay, there are arterioles which are smaller branches, arterioles, essentially non-named branches of arteries. When it gets down to the arterial level, we're talking about non-named branches of arteries. And except for the heart anatomy that we talked about, and whatever the individual anatomy is on the chapters, okay? In other words, you'll need to know the kidney circulation and things like that. And you might need to know a little bit about the GI circulation, but there will not be a whole lot. In fact, there won't be any questions except for heart anatomy that we talked about. And we'll review it next week. Won't be any questions except for this type of structure. There won't be a diagram saying, is that the common iliac artery? Okay. Or is that the internal iliac artery? Is that the common femoral artery? We don't have a practical like that. And there's not any questions on the exam like that. So we have arteries, which are usually named, and then we go down to arterioles, which are smaller branches of the arteries. Okay. Then we have the capillaries. Okay. This is where the distribution occurs. This is 1 cell layer thick. Okay. Capillary is 1 cell layer thick. With a basement membrane, oxygen diffuses out of there, CO2 diffuses in, nutrients diffuse out, waste diffuses into the interstitial space. Okay. Remember, we have spaces. We have extracellular space and intercellular space. Okay. Intercellular space or intercellular fluid is the fluid inside the cell. Extracellular fluid is the fluid outside the cell. Extracellular fluid can be divided into 2 categories. Intervascular, okay, the fluid inside the blood vessels, okay, and interstitial, which is the fluid outside the blood vessels but not in the cells, okay? And so every cell is lined by capillaries, okay? Because how else would you get nutrients to it? How else would you get oxygen to it? And so the cell, the cell has a cell membrane, and in the capillary bed, we can't have 10, 15, 20 layers of cells to try to get nutrients and stuff. And we already have enough problems trying to get stuff through the bilipid membrane, okay, biphospholipid membrane. And so It's one cell layer thick at the capillaries, okay? And then distribute blood throughout the tissue site of nutrient and gas exchange. Then we have small veins, unnamed veins, which are venules. And then as you can imagine, we got bigger veins that carry blood back to the heart, okay? So those are the 5 major divisions of the blood vessels. You can sort of think major interstate, minor interstate, or major interstate. Then you take a branch off the major interstate. You still got a named road, okay? And then you get, a named road, and it goes somewhere else. And so that's what you sort of can think about. They have 3 layers. The blood vessels have 3 layers. They're different in thickness depending on which blood vessel we're talking about. The innermost layer is the tunica intima, okay? The innermost layer is the tunica intima, innermost layer, tunica intima. In contact with blood vessels lined with simple squamous. Remember, we learned back in Anatomy and Physiology 1 that we line blood vessels or line vessels, line a lot of things with simple squamous epithelium, okay? And it's continuous with the endocardial layer of the heart. So essentially we have endocardial layer of the heart, we have the tunica intima going through arteries, arterioles, capillaries, venules, veins, back to the endocardial layer of the heart, okay? Then we have the tunica media, which is the next layer going outward. We're going from inward outward. This is your has smooth muscle that's circularly arranged, okay? And it's arranged in circles, okay? Smooth muscle arranged in circles, because at the capillary bed, okay, at the capillary bed, we might want to perfuse an area. We talked about last semester sympathetic, parasympathetic. If we're in a sympathetic fight or flight reflex, we don't need to, and that T-Rex is chasing us. If you had my class, you understand about the T-Rex. I think of everything in the sympathetic as T-Rex, and then parasympathetic as somebody's hit the T-Rex in the head, and we're all back at the cave sitting down and eating the T-Rex. Well, if we're running from the T-Rex, we want our eyes dilated up. We don't want the lens to focus on fine print. We don't need to read fine print of contract if we're running from the T-Rex. And we need to have a lot of blood going into our heart and going into our muscles, okay? And we don't need a whole lot of blood going into the GI system. Well, we've got capillary beds perfusing the GI system. And how do we close them down? Okay, how do we close them down? We close them down with this smooth muscle, okay? We do the same thing if you look at your arm, okay? If you look at your peripheral vessels in your arm, your peripheral veins, you go outside, okay? You go outside, and that circular smooth muscle around what's controlling the outflow relaxes, and those veins dilate up so you can exchange heat with the environment. As opposed to if you're my son in San Antonio or my brother in Memphis, okay, you go outside, you look, and those veins, that circular muscle has constricted because you don't want to lose any of your internal body heat to the external environment because it's cool there, okay? It's cool there. So that's the second layer there. That's the second layer there. So we had an intima, tunica, okay? Tunica, tunic covering, okay? A media, okay? Can contract or dilate, vasoconstrict or vasodilate. And an external, which is the outermost layer, okay? It has collagen fibers, which reinforce the blood vessel. It has nerve fibers, okay? And if it's a larger vessel, it even has its own blood supply. And that name for the blood supply of the larger vessels, if it's a small vessel, it's not going to have its own blood supply because it'll just take nutrients and stuff from the stuff that's going in between the cells to get out, or through the cells to dilate outwards. But if it's a big blood vessel like the aorta and some of those bigger blood vessels, because it's multiple layers, it's going to need to have blood vessels supplying those multiple layers there. Okay, and that term for that is vasovasorum. Okay. Types of arteries, we've got elastic arteries. We have that pulse, okay, that pulse pressure coming out of the heart. that is going to go out into the aorta, okay? That aorta and the common carotid and the subclavian, the vertebral and the pulmonary are going, and the common iliacs, okay? Remember, we're only going to learn the anatomy for this section, okay? Primarily from the heart, what comes into the heart and what goes out of the heart till we get up to the arch of the aorta. That's we're going to learn the anatomy there, okay? And so that pulse pressure hits that vessel, okay? If that vessel was very firm, then that pulse pressure would be a pulse pressure hitting a firm vessel, and eventually it'd wear it out. But fortunately, in these bigger types of arteries that are either the main branch, the aorta, or some of the first branches off of the aorta, okay, they have elastic fibers in, and so when that pulse hits them, they're going to go out. And when the pulse goes down, systolic, diastolic. Remember, systolic is contraction, diastole is resting. So when that pulse pressure is resting, those elastic fibers are going to cause that vessel to contract. Okay, and so these are elastic, and it tells you the ones they are, and they're approximately 2.5 centimeters. If you need to remember a thing, 2.5 centimeters is 2.54 centimeters is equal to 1 inch. Okay. 2.54 centimeters is equal to 1 inch. And so to remember that, okay, then you've got a in way, you can figure out how many meters, okay, you can figure out, how, what a meter is and how many inches. And so you can do all kinds of conversions with that. That's really the only, that and 1 meter is 39.37 inches are the distance measurements as I remember in the metric system, okay? Not in the foot-pound system that we use, okay? A traditional system, 5,280 feet a mile. But in the metric system, those are the two measurements of length that I remember and having over all these years, okay? So that's our first type. Largest arteries nearest the heart, okay, large arteries. So we're going to look at this multiple times. These are the large arteries. Notice we have systolic and diastolic pressure, highest pressure, fastest blood flow, smooth blood flow. We have the muscular distributing arteries. These are the main branches, okay? You get off of the interstate on 295 onto San Jose Boulevard, that's a main branch, okay? That's a main drag, okay? You keep on going 295 over the Buckland Bridge and you get off at name escapes me now, Blanding, that's a main branch. The other's a main branch that goes by the base, who name escapes me right now. But those are main branches. So we have main branches, the brachial, the femoral, and the splenic arteries. These are distributing vessels, okay, would have muscle, okay, and they could control some of the distribution into that particular area. Notice this green stuff. This is the lymphatics we'll talk about. That is the other it's not really vascular, but it is intervascular space. It's a space that's not interstitial, okay? It's a space that picks up fluid, and so the lymphatic vessels have a certain amount of fluid in them. And they're moderate in size, distribute blood-specific orders, pressure and velocity are decreasing, less elastic, more smooth muscle, more active in vasoconstriction and vasodilatation. We have arterioles. Remember, arterioles are small branches of, they're the smallest branches of the arteries before we go into the capillary beds. The smallest branches of the arteries before we go into the capillary beds. And you can imagine they don't have a name on it, okay? Smallest vessels in the arteria, they're microscopic. These are arterioles here, okay? They regulate blood flow into the capillaries using precapillary sphincters that will dilate and constrict. So here, the sphincters are open. So this capillary bed, we can imagine it can be anywhere. It can be in our big toe. It can be in our liver. It can be in our brain. It can be in our heart. It can be in the quad muscles, the hamstring muscles. But here's a capillary bed, and it's being perfused, okay? Because these sphincters right here that perfuse the capillary bed are relaxed, and that capillary bed's being dilated. as opposed to here we are now. This could be the capillary bed of the GI system, okay? Capillary bed of the GI system. And that we're in that spider flight reflex. The T-Rex is chasing us or whatever, whatever is happening, okay? And we don't need to perfuse the GI system for nutrition, excuse me, for absorption of materials, okay? We still need to perfuse the intestine to keep it alive, but we don't need to perfuse the capillary bed so that we can absorb the nutrients, okay? At the time, we are running on our stored glucose, okay? We're running on our stored glucose to get away from the T-Rex. So in these particular things, these vessel sphincters are now constricted, and you can see that this capillary bed is not being perfused, okay? And what you have now is just a straight through path from your arteriole into your venule, and then into the veins, or into the veins. And so that's what you have to understand about capillary beds. We do this in the lungs too. If you've got pneumonia and got a plug in that alveolus, okay, where that surface that's supposed to exchange air is plugged up with mucus or infection, there's really no reason for that capillary bed to be perfused, because there's going to be no air exchange there, because the air exchange is not going to go on through that collection of fluid and things like that. So we selectively do, I mean, we don't mentally do that, it's selectively done for us, okay? Okay, and the pressure continues to drop. Capillaries, they distribute oxygenated blood to the cells, okay? Capillaries distribute oxygenated blood to the cells. This is the capillary bed. We just looked at it back here. Capillary bed right there. This is a capillary bed. This is where, remember, this is one cell layer thick. It's one cell layer thick with a basement membrane. Distribute oxygenated blood to all cells, going to take up CO2 from the cells, and put it back into, this is the capillary bed in the lungs, take up CO2 from the cells, and it will go into the alveolus, okay? Smallest vessels with the thinnest wall, average of a 1 millimeter, that's a thousandth of a meter, okay? 1 millimeter is a thousandth of a meter. A micrometer is a millionth of a meter, okay? A nanometer is a billionth of a meter, okay? And a picometer, so that would be 10 to the minus 9. The picometer is 10 to the minus 12 of a meter. So I would, you know, as a general rule, I just try to give you hints. Those were the 4 I would learn, okay? 4 I would learn. You know, milliliter, if you have IV solution, it comes in a liter that has 1,000 milliliters. And you say, I'm going to give them 500 milliliters, okay? I'm going to give them half of the liter, all right? Near every cell body, but number depends on the tissue they serve. Obviously in the brain, there's a lot. Obviously in the heart, there's a lot. Obviously in the muscles, there's a lot. If there's where the digestion's going on, there's a lot. On the, you know, on the backside skin, very thick, probably not a whole lot of capillary beds, okay? I mean, there's enough capillary beds to maintain the you know, the viability of the skin, okay? But more capillary beds in the more essential tissue. A lot of capillary beds in the kidneys, and specialized capillary bed. Low pressure, slow velocity. Exchange materials between the blood and the interstitial fluid. So remember, it doesn't go from the blood into the cell, it goes from the blood into the interstitial fluid, which surrounds the cell and surrounds the vessels, okay? That capillary bed is literally next to the cell, okay? But, you know, there is a space there, okay? And the space is not empty, it consists of fluid, and that's interstitial fluid. That's extravascular fluid called interstitial fluid. And I'll tell you, that was not a light bulb moment for me in medical school. That just, the light bulb just never went off, okay? It just never went off. I mean, I memorized stuff. If we had to memorize it for, if it contained a certain amount of volume, I would memorize it. But it just, that was one of those light bulb moments that didn't go off for years and years. Probably didn't go off until I started teaching that class. Walls of capillaries, basement membrane with a single layer of endothelial cells, okay? Exchange of materials between cells and capillaries, nutrients, gases, other small molecules diffused by diffusion, but also crosses and forced out of the capillary by hydrostatic pressure. We'll talk about great detail when we get to the capillary bed about this hydrostatic pressure. That's the pressure that's going to force the fluid out of the capillary. Okay, the capillaries are leaky. Okay, capillaries are leaky. They're only 1 cell thick. Okay, when we got a basement membrane, they're leaky. And if you've got a high pressure end and a low pressure end, the high pressure end is going to force fluid out. The low pressure is going to force fluid out, but not as much. Okay. Types of capillaries, we've got continuous 4 nanometer clefts. How much is a nanometer? Well, we said a millimeter was 10 to the minus third. A micrometer, okay, or microns 10 to the minus 6, okay. Microns you ought to know because a red blood cell is 6 to 8 microns across, okay. A nanometer, which all of you, if you're going into, actually, if you're going into anything, you're going to be dealing with nanotechnology, okay. That is nanotechnology. And that's 10 to the minus 9. And you'll probably get into picometers, okay? That's 10 to the minus 12. So those are useful to know because that's 4 billionths of a meter, okay? 4 billionths of a meter. It might be a great thing to pull out of your head one day when you're doing your internships or your rotations and somebody asks you a question, because the metric system is Greek to most people in the United States. Do you know we actually lost a satellite. It was something that was going to another planet because part of the people calculated in our foot pound system and part of the people calculated in the metric system, okay, and they got the measurements wrong and they got it too close to the planet, too close to wherever they were going to. It was overtaken by gravity, okay, it was overtaken by gravity, and it crashed, okay, it crashed. And so that was one of our big faux pas because of not using the metric system. Fenestrated, 20 to 100 nanometer holes. Remember, nanometers 10 to the minus 9, it's a billion. We have sinusoids, which are blood-filled spaces. When we get to reproduction and talk about the placenta and where exchange goes in the placenta, we'll talk about sinusoids. And incomplete basement membrane. So we have a whole lot of ways that these can be leaky, okay? We have venules, which are the joining of the capillary beds, okay? Thin wall, but relatively impermeable, okay? Except for the smallest ones. And so, in other words, the ones that are right next to the capillary bed are still fairly porous. They're still fairly leaky, okay? And so that fluid that doesn't come back into the vessel actually gets absorbed by the lymphatic system here, by the lymphatic system. It actually gets absorbed by the lymphatic system and is drained back into the vascular system. Pressure still falling. Pressure continues to fall, okay? We have veins joining in the venules, same layers as arteries. The layers are not as thick, okay? There are our conducting vessels, just like our arterioles were conducting vessels, to conduct stuff away from the heart. They are vessels that are going to coalesce and are conducting vessels back to the heart, okay? Because no exchange, once you get to the level of the bigger venules, okay, into the veins, no exchange is going to occur. Just like in the arteries and arterioles, there's no exchange occurring there. Those vessels are too thick, okay? The exchange occurs in the capillary bed, whether you're talking about oxygen, whether you're talking about gases, whether you're talking about nutrients, whether you're talking about waste products, whether you're talking about vitamins, whether you're talking about hormones. It occurs in the capillary beds, okay? So we're not talking about exchange anywhere else here, okay? Larger lumen but thinner walls versus arteries, okay? Blood reservoirs only partially filled. Remember, we got very low pressure. We don't have, the heart by this time has pumped blood all the way halfway through the body. And now the blood not only is furthest away from the heart, but it's working against gravity because most of us are standing up or sitting down, okay? And so a lot of this blood is working against gravity. One-way valves, so there are in the veins, there are one-way valves so that when the blood goes into that vein, just like the semilunar valves, the pulmonic and aortic semilunar valves, those valves flop back down to keep that blood from going back to where it just came from and never getting back to the heart. Physiology of venous return, pressure gradients. No, nobody's going to ask you, what the pressure is in the artery and arterioles and the capillary bed and at the venules and the veins. You just need to have a general sense of it, where it's at the highest and where it's the lowest. Skeletal muscle, our gastrocnemius is pumping blood right now. If we're moving our gastrocnemius, and we should be, okay, if she's pumping blood upwards, okay. Our respiratory pump, when we inhale, we decrease the pressure around the heart, and that causes blood to flow in, okay. So we have a skeletal pump, we have pressure gradients, we have the valves, we have skeletal muscle pumps, we have a respiratory pump, and smooth muscle constriction in the veins, sympathetic stimulation. If we need to, and we get a low blood pressure or low volume, we will clamp down on most of the non-essential things, so that we can get our return back to the heart. Collateral circulation, we can develop anastomoses, okay, to provide collateral circulation, okay. We also have areas of the collateral circulation in our joints, in our brain, primarily in the circle of Willis. There's a circle. We won't go over it. If you were in the neuroanatomy class, you would, but we won't go over it. There's a circle of Willis where the blood supply comes into, and multiple branches come out from there, so that if you have an infarction in one area, you might be able to get some blood flow into that area, or if you have an occlusion, you might be able to get some blood flow into that area by way of the circle of Willis. We have a portal system, okay? Portal system means you have two capillary beds. The one that we're going to deal with the most will be the hepatic portal system, okay? When we absorb nutrients, okay, from the GI system, those nutrients have to be processed. And most of the processing goes on from the liver. Well, it wouldn't be a energy efficient system if we had veins from the GI system that were taking the blood back to the heart, and the blood pumps the blood out to the heart, from the heart into the systemic circulation. And part of it with the nutrients goes to the liver, but part of it doesn't. And it doesn't matter if the nutrients are there, gets to the capillary bed, because they haven't been processed, okay? They haven't been processed. In other words, we may need to put some things together, okay? We may need to break some things down. So we have this circulation called the hepatoportal circulation. So the veins of the GI system drain into the portal vein. The portal vein is a major vein going into the liver, okay? And so the portal vein goes into the liver, and these things that are processed are going to be processed in the liver, okay? We have some processing excretion in the kidneys, but primarily just excretion or secretion in the kidneys. But this is where a lot of it's going to be processed in the liver. So instead of sending out the systemic circulation, and maybe the liver, I'm making this number up, is 10, I used to know 10% of the blood supply. So every turnaround will get 10% of those nutrients. If it was efficient, the other 90% would be out where they can't be used. So we take those nutrients, things that we have broken down, the proteins, the carbohydrates, the lipids, and the nucleic acids. That's our 4 macromolecules that we're learned about in Anatomy and Physiology 1. And we take that by way of the portal vein, and it gets processed in the liver. And then the hepatic vein, which is right behind the liver, drains directly into the inferior vena cava. So that is a portal circulation, okay? And that's the one that we're going to talk about a little when we get to the GI system. And this is just a schematic of it. If you know what I just said about it, you know the gist of everything you're going to need there. Blood flow, blood pressure, and resistance, okay? Definition of terms: blood flow is the volume of blood flow that flows through a tissue at a given time. We have cardiac output. Remember, this is a heart rate by our stroke volume, heart rate by our stroke volume. We remember that our stroke volume is about 70 milliliters. How this becomes distributed is dependent on the pressure difference, the driving forces high to low, and the resistance in specific vessels, to how much friction. If we get to a system that has a lot of branching, okay, there's turbulence there, okay? If we get to a system that has a lot of branching, there's turbulence there. And with that turbulence would be increased resistance, okay? Blood pressure, force per unit area. Pressure is force per unit area, okay? That's what pressure is force per unit area. Force per unit area. So force per unit area exerted on the blood vessel wall is what we're measuring when we measure pressure. That's literally what we're measuring when we measure our tire pressure is tire pressure, and it's force per unit area. Systolic pressure, highest pressure term during ventricular contraction, systole. Diastolic pressure, lowest pressure during diastole. Pulses in our arteries, the blood enters intermittently due to ventricular contraction. Blood enters intermittently due to ventricular contraction. Expansion and recoil of the arteries, especially in the elastic arteries. At height of the pulse, the systolic pressure can be measured. Normal is 120. At the lowest point, between when the heart is not contracting, we measure the pressure again, and that's the diastolic pressure. Normally 70/80, so 120/80. That's the standard blood pressure. Some people may be a little bit lower. My mom's blood pressure was 90/70, 90/60. That was her normal blood pressure, okay? And there was nothing wrong with that, okay? But with the numbers we learned are 120/80. Okay? 120/80 reflects the force of the contraction of the left ventricle. Diastolic pressure reflects the condition of the peripheral vessels. In other words, what's the pressure in the vessels when the heart is resting, which is one of the most important things. Because if the pressure is high in the vessels when the heart is resting, then that's going to have a detrimental effect on the heart. Okay. Pulse pressure is systolic pressure minus diastolic pressure. Difference in what keeps blood moving, high to low. Taking pulse, pushing on the vessel. Everybody can push on the radial artery. You can push on your temporal artery. You can push on your carotid artery. If you don't push very hard, you got your femoral artery pulse. There's, you got your dorsalis piece and posterior tibial in your feet. There's all kinds of pulses where you can take pulses from. Taking pulse involves pushing on the vessel to feel the systolic pressure. Okay. Pulse rate 75 average, 60 to 80 can be measured in various areas. Femoral, we got radial, we got brachial, okay, we got carotid, okay. You can measure it at the jaw line, you can measure the temporal artery, you can measure popliteal pressure, you can measure posterior tibial and dorsalis pedis. Arterial pressure is the average pressure in the arteries, okay? And we take into account that diastolic is longer than systolic, okay? So when we calculate that, and if there's a problem you need to calculate it, you just come right to this slide here. Diastolic pressure plus 1/3 of the difference between the systolic and the diastolic. So the diastolic pressure, if it's 120/80, would be 80 plus 1/3 of the difference. 120 minus 80, that'd be 40. And 1/3 of that is 13 1/3. So 80 plus 13 1/3 is 93 1/3. Okay. Can you do that in your head? Okay. Without doing it in a calculator. If you haven't heard from me about this, you're going to need to relearn to be able to add, subtract, multiply, and divide without a calculator, okay, during the great zombie apocalypse, because we won't have any batteries and your solar calculators will soon lose their power. Well, and part of the reason I can do it so well, or could do it so well, was when I grew up and went to college, we used slide rows. Slide row is a piece of wood with a bunch of markings that you slide. Two pieces of wood. You had a piece in between. You slid things between it. That's how they landed on the moon, was a slide row. And so it was a whole lot easier for me just to learn to do a lot of calculations in my head. So if you're asked the question for the mean arterial blood pressure, it's the diastolic blood pressure, which is the low number, and you're given a pressure, okay? Diastolic blood pressure, which is the low number. In our particular thing, if our blood pressure is 120/80, it'd be 80. If our blood pressure is 150/90, it'd be 90, okay? And if our blood pressure is 150/9, what's our mean arterial blood pressure? There's 90 plus 1/3 of the difference between 150/90, 150/90. That's 50 plus 10, because 90 is 10 from 100. 100 to 50 is 50. That's 60. 1/3 of 60 is 20. 90 plus 60 is 110, okay? So just by that little difference in blood pressure from 120 over 80 to 150 over 90, we now have, okay, and see, part of the reason of that is because you add the whole diastolic pressure, and then you add a third more of the diastolic pressure. So the diastolic pressure takes a lot into account. You can also measure this if you know the cardiac output times your resistance. Well, resistance is something you'd have to be given. You're not going to do a question on that. Factors increase blood pressure, increase in stroke volume, increase in blood volume, increase in heart rate, increase in resistance, okay? Resistance is due to the friction between the blood and the walls of the blood vessels. If you have atherosclerosis, if you lay down plaque in the blood vessels, those blood vessels will narrow. Well, you're still pumping out that same 70 milliliters, okay? Before you had this nice big lumen, okay? Before you had this nice big lumen, you noticed you had a good radius there, and now your radius is smaller, okay? And so when you do that lab 19 activity 1 on the radius, you will see the effect of radius on blood flow. You will see the effect, and it'll tell you to adjust the radius to this and click, evaluate or whatever it is, and it'll come out, and then it'll come out with all the numbers, and you just click upload the data, okay, and it comes out with all the numbers. Dependent on blood viscosity, so if you have too high of a hemoglobin in the hematocrit, if you have too many red blood cells or too much hemoglobin, okay, you're going to increase the blood viscosity. Dehydration also does that. Anemia decreases it because you have less hemoglobin, less red blood cells. Total blood vessel length for every kilogram, okay, here's my next measure. This is a measure of weight, okay? This is a measure of weight. A kilogram is 2.2 pounds. A kilogram is 2.2 pounds. That's another measure of weight. You add another, so for every 2.2 pounds, it says you add 650 kilometers of blood vessels. Now, I don't know where you got that off slide. It may be in the book. I've not looked it up, but that's a lot of blood vessels for each kilogram of fat. Okay, a lot of blood vessels for each kilogram of fat. So that's another reason not to be obese, because the heart has to pump that through all that whole circulation. Okay. Blood flow is fastest in highest pressure, largest diameter. You're going to do the radius, so you'll see that. Blood flow is slowest and lowest pressure, smallest diameter. Okay. Resistance varies inversely with the fourth power of the radius. If you double the radius, you have 1/16 of the resistance. Okay. And you'll see that on that example. You don't have to do any of the calculations. You just do the numbers and you click. I forget what the button says, click run the experiment, whatever it is. And all the numbers just pop up. So you don't have to do any of that. Now, if you were taking physics, if you're somebody that takes physics and you get to fluids, okay, that's one of the parts of physics, fluid dynamics, you would be doing the calculations, okay? Blood picks up speed in venules and veins as low pressure is compensated by larger diameter. Low pressure, so it picks up speed, okay, as low pressure, but it's going faster. This is our relationship of area and our relationship of velocity. Higher velocity in the major arterioles, low velocity in the capillary beds as the area increases. As the area decreases, as we go out of the capillary beds into the venules, okay, and into the vena cava, you can see that the velocity picks back up. Never really gets back to what it was in the arterial system, or never gets back to the arterial system, but it does get back to a reasonable pressure to get the blood back. Maintaining blood pressure, short-term mechanics, what can we do? We got vasomotor sensors in the medulla. If you see the word baro, baro means pressure. That's what a barometer tells you, pressure, okay? Baro means pressure. So these receptors are going to sense pressure, okay? Sense arterial pressure in the carotid sinus and the aortic arch, okay? Higher than normal pressure stretches them, leading to increased signals to this center, increases the peripheral nervous system, parasympathetic nervous system, and decreases the sympathetic nervous system, decreases heart rate and strength of contraction, decreases activity of sympathetic nervous system blood vessels, leading to arterial vasodilatation and decreased peripheral resistance, lower cardiac output. So high pressure, we get signals in to the medulla. It says, hey, decreased sympathetic nervous system. Remember, your blood pressure goes up when you get nervous, okay? Decreased sympathetic nervous system, increased parasympathetic nervous system. What's parasympathetic nervous system going to do? Decrease the heart rate, decrease strength of contractions, okay? Lead to arterial and decrease activity, leading to arterial vasodilatation. So sympathetic nervous system, arterial vasodilatation, decreased peripheral resistance, decrease activity of sympathetic nervous system. Here, what's peripheral nervous system going to do is decrease the heart rate. If you ever want to get your heart rate down, take slow, deep, square breaths. 5 seconds in, hold it for 5 seconds, 5 seconds out. 5 seconds in, hold it for 5 seconds, 5 seconds out. And so if I get anxious and my heart's beating really fast, I start square breathing, okay? So you can use that as a technique if you have an anxiety provoking situation. Say you're going in for an interview, you're going in for a big test, it's called square breathing, okay? And it's just 5 seconds. It can be 4 seconds. It can 5 seconds in, hold it for 5 seconds, 5 seconds out. And you know, some people got this thing, you breathe in through your nose and out through your mouth. It really doesn't matter. It's all the same air, but whatever you want to do. And it could be 4 seconds if you want to, or it could be 6 seconds if you wanted to, but it's just called square breathing, and that will bring your heart rate down. And if you bring your heart rate down, that usually brings your anxiety level down, okay? So try it sometime next time you get anxious, okay? And because that's literally what they tell you if you're in a panic attack, okay? Is to do diaphragmatic breathing. In other words, breathe with your diaphragm. Put your hand on your belly, okay, right below your thorax, and feel your diaphragm drop down because your abdomen will expand. Okay, your abdomen will expand with breathing, as opposed to just doing chest breathing and very superficial. Okay, and you'll just provoke your anxiety. So the baroreceptors sense arterial pressure. If we got falling pressure, it's just the opposite. We're going to decrease the peripheral nervous system, increase sympathetic nervous system. We're going to get a little squirt of epi and norepinephrine, increase heart rate, strength of contraction, higher cardiac output, leading to arterial vasoconstriction and increased peripheral resistance. We got to jack the blood pressure up. Baroreceptors, okay? So that's our first type of receptor. What does baro mean? Pressure, okay? Where we're going to measure at in the carotid sinus and the aortic arch. Carotid sinus and the aortic arch. How much are we perfusing the head? Okay, carotid sinus, that's going up to the brain. Okay, how much are we perfusing the head? And what's the pressure as it comes out of the heart? You know, what is in the aortic arch? What is it as it comes out? Now we got chemoreceptors, okay? So baroreceptors, if you can figure out some, and that's not, it's just like simplistic way to understand this, then it makes it easier, because you'll have baroreceptors and chemoreceptors in the lungs and everything else, and in the kidneys, okay? Since low oxygen, low pH, high CO2, carotid body and aortic bodies, increased sympathetic outflow, vasoconstriction, speed up blood flow to return to the heart and lungs, okay? Hormonal control, we have angiotensin II, vasoconstrictor, need ACE, angiotensin converted enzyme. ACE inhibits lower blood pressure, okay? ACE inhibits lower blood pressure. One of the most common medications for high blood pressure is an ACE inhibitor. I take an ACE inhibitor, okay? And so it inhibits this enzyme, okay? And so if this enzyme causes a vasoconstriction by way of angiotensin II, okay, then I don't want vasoconstriction because I already have high blood pressure, okay? And so if you inhibit this enzyme, so if somebody tells you if they say they're on an ACE inhibitor, that's what they're talking about. It inhibits this enzyme. This enzyme is one of the mechanisms that the coronavirus uses, because this angiotensin II is coming out of the lungs, that the coronavirus uses to enter lung tissue. Okay, I don't know anything about it. And so there's some concern and some talk about people who are taking ACE inhibitors and the pandemic that's going on. And there again, that is the extent of my superficial knowledge about that. Okay. Antidiuretic hormone. Okay. Diuresis is putting fluid out. That's usually if you have high blood pressure, but it's not too high, they'll give you a diuretic to bring off excess fluid. If we don't want to have a diuresis, if our volume is low, okay, one of the things we can do is have an antidiuretic hormone. What antidiuretic hormone does is retain water and cause vasoconstriction, okay? And where it retains that water is in the, after the urine has been filtered and things have been excreted and secreted in, and when we get the kidney chapter, you'll understand all that. It all goes into some collected tubules that's going to go into some calyces, that's going to go into the ureter, that's going to go down to the bladder. Well, the antidiuretic hormone actually puts in channels called aquaporins for the water to come out of the collecting tubules, because if it's in the collecting tubules, that means it's going to go out as urine. And so if we have an antidiuretic hormone, okay, if we have an antidiuretic hormone, we don't want the water to go out in the collecting tubules and go out as urine. We want to bring it back in to the kidney proper, so it can be reabsorbed. And so that's what antidiuretic hormone. And when we get the kidneys, we'll talk about these. These things are just very superficial surveys of things that we're going to talk about more extensively when we get into the other systems. Okay. Retain water, vasoconstriction, epinephrine and norepinephrine, vasoconstriction in most vessels, vasodilatation in the heart, and the skeletal blood vessels. This is the big hormones of the sympathetic fight or flight reflex, vasodilatation, heart, skeletal muscles. We need to be able to pump some blood and to run away from that T-rex. Okay. Nicotine will also cause vasoconstriction by directly stimulating sympathetic neurons and prompting release of epinephrine and norepinephrine. Atrial natriuretic factor, atrial ANF. Okay. This is a factor released in the atria, secreted by some atrial cells when blood volume and pressure gets too high. You know, the atria is thin-walled. It can sense the pressure. In other words, pressure is too high. And so what it does, aldosterone we didn't talk about, but it's a hormone, okay, that causes the kidney. Normally, aldosterone would preserve sodium, okay? It would preserve sodium. And if you preserve sodium, sodium is an ion, it's a cation, it's a positively charged ion. Because it's positively charged and because water is a covalently ionic compound, it surrounds the ions, okay? It surrounds the ions, so it surrounds sodium. So if you pull sodium back into the system, you're pulling volume back into the system. So that's what aldosterone does in a nutshell. It pulls sodium back in, and if it pulls sodium back in, it's pulling water back in, and so you're increasing the volume into the intravascular space, so the pressure is going to go up. Okay. Well, if the pressure is too high, as sensed by the atrial cells, it's going to antagonize this aldosterone, causing the kidneys to excrete the sodium, and the water is going to go with the sodium. So it'll excrete the sodium. Sodium will get into the collecting tubules. The water will be with it. Okay. And then they will go out and the volume and pressure will go down. Okay. Long-term mechanics alter the blood volume, renal regulation, renin-angiotensin mechanism. You won't get a question on this module, but when we get to kidney, we'll talk about this. Angiotensin is above, ADH to reabsorb water, aldosterone to absorb sodium, activate thirst mechanism. That was indirect. Direct. Kidneys can secrete more or less water if necessary without hormonal influence by increasing or decreasing the speed of filtration. They have that circular muscle around the afferent vessels or efferent vessels to increase or decrease filtration. Autoregulation, because it's controlled locally. Declining O2 levels, you're going to get vasodilatation. And also be indirect release of nitrous oxide. Nitrous oxide is a chemical that if you go into one of the gyms, they'll want to sell you a big thing of nitrous oxide or say nitrous oxide pills. It's also the active component. Excuse me. Most of the Medications for erectile dysfunction cause a increased release of nitrous oxide, and that nitrous oxide leads to vasodilatation. Okay, I mean it's used in a number of other places too, but that is one of the places that it's used. Some of the erectile functioning drugs like Cialis is actually used for pulmonary hypertension. That's what it was being used for. Okay, and this other effect that it has was actually a secondary effect. Okay, it was used for pulmonary hypertension. I believe that's the way Rogaine was discovered. Okay, I can't remember exactly. Open and closing precapillary sphincters. You won't be asked a question about that. Okay, I just thought I would throw that in because it is you'll see a lot of clients that maybe own these medications. Okay, either for pulmonary hypertension or for erectile dysfunction. Okay, have you ever noticed the TV commercials now for medications or diseases? They're all abbreviated. All the if you got the big eye because of a thyroid defect and too much thyroid hormone and your eye bulges forward, and you have exophthalmos, they got an abbreviation for that. It's 2 or 3 letters. Opening and closing the precapillary sphincters. We have a myogenic response. You're not going to get any questions on these, but these are just responses that are here. Okay. I already told you the big ticket item coming out of this chapter we haven't got to. Passive stretching causing increased contraction to slow blood flow. Reduced stretch promotes vasodilatation. So if you got reduced stretch, you're going to get vasodilatation to increase blood flow. If you got increased stretch, you're going to vasoconstriction. Angiogenesis, growth of new blood vessels. We would like to have new blood vessels. We'd like to exercise and have a lot of collateral circulation in the heart. So if we do get ischemia there, we got some collateral circulation. Blood flow in skeletal muscles, most strenuous situation for the cardiovascular system. CO2 builds up, O2 decreases. We got brain, muscles and brain. Most metabolically active organ requires constant and consistent blood flow. So we got all those regulatory mechanisms and a lot of the receptors. Remember, the baroreceptors, pressure receptors were in the carotid sinus. We had chemoreceptors in the carotid sinus. We'll see later on we have more receptors up there, but we want to ensure. And then the other receptors are located in the aortic arch. To see what's coming out of the heart. What's the situation there? If you sample the like you want to sample discharge from a company, you don't go down. Well, you could go downstream, but you'd like to sample it literally right when it comes out of the pipe, drain right into the St. Johns River to see what they're actually putting into the system, unless the pipe's under the ground, or not underground, but underneath the water. Autoregulator stimulus very, very little, but sensitive to changing CO2s, low pH causing vasoconstriction. Lungs, low pressure, exactly the opposite. Low O2 in the area, lung generates vasoconstriction. So if we have an area with low O2, okay, there's that pneumonia area, low O2, the oxygen's not getting into the alveolus. There's not a whole lot of reason for us to perfuse that capillary bed because no exchange is going to go, okay? Whereas if we have a high O2 area, okay, so we're getting a lot of oxygen into an area. So if we got areas with high O2, that area is going to have the capillary bed dilated so that we can have more exchange going on, okay? Aneurysm is a dilation, saccular aneurysm, fusiform aneurysm, and ruptured aneurysm. You can have aneurysm structure in the brain. You can have aneurysm structure in the aortic arch. You can have aneurysm rupture in the abdominal aorta. You can have splenic aneurysms rupture, okay? So there's all kinds of places, varicose veins. What happens if these vein valves are incontinent, okay? If these vein valves are incontinent for a number of reasons, a lot of it's hereditary, but it can be from prolonged standing or for pregnancy, then that blood flow flows back into those veins and those veins dilate up. And the more they dilate up, the more deformed they get, okay? Orthostatic hypotension, decrease in blood pressure when one stands up, result in dizziness and syncope due to sluggish barrel reflexes. Arteriosclerosis, hardening the arteries become less elastic. Systolic and diastolic blood pressure rise. So if you have somebody that's 85 or 90 years old, their normal blood pressure is probably not 120 over 80, okay? is probably a little bit higher because they have arteriosclerosis. Okay. Capillary dynamics, capillary exchange, big ticket item, 10-point discussion question on your exam on capillary exchange. Okay. Simple diffusion through fenestrations, intercellular clefts of the membrane itself. Okay, includes O2, CO2, glucose, amino acids, all plasma solutes. Exceptions are proteins. So we have the proteins inside the vessels that are too big to go out, and we have the cells inside of the vessels that are too big to go out. And then we have some other macromolecules that are too big to go out inside of these fenestrations, inside of these holes. Remember, they were nanometers. Okay. They were nanometers in size. They were billionths of a meter in size, okay? Brain capillaries are non-fenestrated with tight junctions because we have a blood-brain barrier. Fenestrations and filtration and reabsorption. Bulk fluid moves along the membrane along with nutrients and gases. So at the arterial end of the capillary bed, we're going to have fluid move out. At the arterial end of the capillary bed, we're going to have fluid move out. We're going to look at that in just a minute, okay? Forced out of the clefts at the arterial bed, side because of the hydrostatic pressure. The pressure inside of the blood vessels to force it out. Return to blood so this bulk fluid, okay, except for the nutrients and gases, is going to return to the blood of the venous end. The direction and amount of fluid that moves is dependent on two types of forces: net filtration pressure, the hydrostatic, which is dominant, okay, at the arterial end. So that's the pressure, that's hydrostatic pressure that's pushing the fluid out, pushing the gas out, pushing the nutrients out. Net absorption pressure, which is the colloidal osmotic pressure. Colloidal osmotic pressure are those proteins and those cells. And remember, most everything is charged, okay? Most everything is charged. Remember, the body has a total neutral charge, but a lot of the things in the body, especially big proteins and a lot of our big molecules, are charged. So if they're charged, they're hydrated, okay? If they're hydrated, they are pulling fluid in, okay? Remember, that fluid got pushed out, okay? Well, all of it didn't get pushed out because some of those macromolecules are holding on to that water. We talk about water because, you know, blood, interstitial, intervascular, extracellular, intracellular, majority of fluids, water, are holding on to that fluid. Okay, so we got two things working. We got hydrostatic pressure pushing out, and we got colloidal osmotic pressure pulling the fluid in. Okay, so we've got one pressure. So if one was 50, if the hydrostatic pressure was 50 pulling out and the colloidal osmotic pressure was 25 trying to keep the fluid in, we'd have a net pressure, okay? We'd have a net out pressure of 25, and if we were measuring millimeters of mercury, 25 millimeters of mercury, okay? So we have two pressures we're looking at. We're looking at pressure out. We're talking about the stuff inside the vessel, okay? There's a pressure to try to push the fluid out, but there's also a pull from inside the vessel trying to retain that fluid because those molecules are hydrated and they don't want to give up the fluid that's around them, okay? A force gets vessel walls due to fluid pressure. Hydrostatic pressure of the capillary, HPC, is higher at the arterial end than the venous end as pressure drops to the capillary. That makes sense. Hydrostatic pressure is higher at the arterial end than at the venous end as the pressure drops to the capillary. Hydrostatic pressure of the interstitial fluid, that IF means interstitial fluid, opposes movement, okay, of the fluid out. So we actually have a fluid pressure, okay? We have a fluid pressure in the interstitial fluid because interstitial fluid is made of fluid, okay? So we have a hydrostatic pressure inside of the capillary, arterial and venous end, that's trying to push fluid out. We have a hydrostatic pressure in the interstitial fluid that's trying to oppose that movement, okay? So we have hydrostatic pressure both in and out, in the capillary, inside the capillary, and in the interstitial fluid, okay? Hydrostatic pressure capillary is about 35 millimeters at the arterial end. So we got This is arterial end. We got 35 millimeters trying to push fluid out, and about 17 millimeters at the venous end. All right, so that's pressure trying to push stuff out. Hydrostatic pressure is interstitial fluid, and I think they went ahead and did the calculation, and this is the number. So they're using 0 at both ends. So the pressure of the interstitial fluid trying to push in is 0 at both ends. So we've got arrows of 0 and 0 at the arterial end and the venous end. So far, all we're talking about is hydrostatic pressure. We're not talking about fluid osmotic pressure. At the arterial end is 35, at the venous end is 17 for inside the capillary, HPC. For hydrostatic pressure in the interstitial fluid, it is 0 at both ends. Net filtration pressure, 35 out, 0 in, 35 out at the arterial side, 17 out, 0 in at the venous side, okay? So all fluids going out both ends. So if all we had there was just those two pressures, we'd have a total of 52 net pressure going out, net filtration pressure going out. All our fluid would literally leave our vessels, okay? Colloidal osmotic pressure, concentration of large non-diffused molecules, primarily proteins. These represent proteins, okay? These are proteins. These are the negative charges inside the cell. They're all saying, what's the negative charges inside the cell? The negative charges inside the cell are primary proteins, and they cannot get out of the cell, so you can manipulate the positive charges, the sodium and potassium, and that's how you get depolarization, repolarization in the nerve, okay? If you think about it, that literally is how you get depolarization, repolarization, because the cell is going to maintain inside is negative because of the proteins. To get it to go positive, you got to get a lot of positive charges going in. To get it to go negative, you guys get a lot of positive charges go out. And so I'm telling you, if you can reduce things down to the lowest common thing that you think about, then you can, it makes a lot of sense, and you can almost understand it sometimes, okay? These molecules draw fluid in towards them. So the osmotic pressure of the capillary is 26 at both ends, okay? They're showing it pulling in. The proteins are actually inside, but what they're doing is they're pulling inwards, okay? They're pulling inwards. So osmotic pressure is 1 out at both ends, because remember, we have large non-diffusible molecules in our interstitial fluid, okay? In our interstitial fluid. So we've got 1 out at both ends there, okay? So we got 1 out. So this is the capillary. Although the air is pointing in, it's because these proteins are in here trying to pull that fluid inwards, whereas the pressure is trying to push the fluid outwards. We have proteins out here, not very many, because the colloidal osmotic pressure in the interstitial fluid is only 1, okay? So let's see, net absorption pressure. At the arterial end, we got 35 out, we got 26 in and 1 out. So 26 minus 1 is 25. We got 35 out and 25 in for 10 out. Net arterial pressure, net is 10 out at the arterial end. Net filtration pressure here, okay, what do we have? We have 17 out, we have 26 in, we have 1 out. We have 17 out and 26 in and 1 out. So we have 17 out and 25 in. 17 out and 25 in is -1, okay? -1 in, okay? Or 8 in, excuse me, we're talking about in. So it's 8 in, we're pulling in, okay? So we got 10 out and 8 in. We got a net of 2 out. So however we're measuring this pressure, in an ideal situation, and hopefully this is what's happening in you right now, in an ideal situation, we have a net of 2 out, okay? We have a net of 2 out. And so this is this little diagram, but probably this is the picture in your book with all this explanation. So I like this little diagram. I like starting at back here at this slide and going forward, okay, and learning about this. You don't have to memorize any of this because remember, you're going to have access to your slides on your exam, okay? So let's think about a scenario. What if we had somebody who was malnourished, and these are proteins. If you're malnourished, you're not going to have as many proteins. And so if you reduce this number by a third, what's going to happen to that number? It's going to be reduced by a third. If you reduce, number is going to be reduced by a third. If you reduce this number by a half, that number is going to be reduced by a half. So that'd be 13. So you can see now that would make a difference, right? And so if you reduce that, if that's 13 now, okay, that would be 35 out, 13 in, 1 out, that'd be 12. So we got 35 out, 12 in. So what do we have now? 35 minus 12, that's 23 out. We have 17 out. We have 13 in, 1 out. So we have 18 out, 13 in, 18 out, and 13 in. That's 5 out. So everything's going out. So we'd have a whole bunch of fluid going out of this situation if we had a person that was malnourished. We had a person that was malnourished. And so I don't think this is a very hard concept. And so your question is essentially, what happens if everything else stays equal, but we reduce the amount of protein inside the vessel by a certain amount? It might be by 25%, it might be by 33%, it might be by 50%. All you have to do is take this scenario here, change these numbers, and change these calculations and come up with the numbers. And that's a 10-point question. That's your last question on your exam. Because this is essential for understanding. This is essential for understanding because right now we have only 2 out. Okay, we have 10 out and 8 in, so we have 2 out. And that net of 2 out is picked up by the lymphatics, which we'll talk about next time. In result, 85% of filtered fluid will reabsorb. Lymphatic system picks up the rest, 1.5 milliliters per minute. Homeostatic imbalance, we get edema, okay? There's a number of reasons for getting edema. One of them is if the lymphatic system is disrupted. Say, when we were doing breast cancer, when I was a general surgery resident, and back then the treatment was modified radical mastectomy and axillary dissection. So you were taking the axillary lymph nodes out. And if you're taking the axillary lymph nodes are in the channels of that lymphatic system stuff that's draining eventually into the internal jugular vein. So all of a sudden you no longer had a drainage system to drain that excess out. Okay, it was supposed to go back into the lymphatic system. So a lot of patients got arm edema. So you had to put a compression garment on their arm if they started developing arm edema. Same way here, if you did groin dissection, say you had some kind of thing that had metastatic lymph nodes. And now they no longer do that. If it's what we used to do modified radical mastectomies for an axillary dissection, they now do just excise the tumor and sample a lymph node, or do a lymph node sampling, any of them that are big, and they sample them. And so it's much less invasive procedure and may be able to maintain the majority of volume and majority of shape. Before I was a surgery resident back in the day, they were doing radical mastectomy. So they took the entire breast, the skin over the breast, and the pectoralis major muscle for significant deformity. So breast cancer treatment has evolved just in my lifetime, and things will evolve in your lifetime. So if we got increased, why do we get edema? Increased capillary function, increased blood pressure, poor venous return. As you age, you go and see the doctor, they'll go down and they'll go along your tibial bone, especially as it gets down towards your ankle, to see if you have any pretibial edema. Okay. See if you have any edema in your legs. Is your heart not working? Okay. Reduced capillary absorption, blood albumin. Guess what? That's the one. Reduced capillary reabsorption causes edema. So if you had a question on your test, well, if you had reduced blood albumin, which are the proteins, albumin is the number one protein in blood. We already learned that. What would you get? Edema. You would not believe the answers I got. So you can see I can see from the people that went to the review, because what we'll do is this will be one of the things that we will review in the review again, because I just told you this is the last question on your exam. And I just told you the setup. And if we have obstructed lymphatic drainage, you can get the lymphs obstructed with cancer. Okay. And that's the end. So who has questions? Let me look at the chats if anybody has any questions. A few days, but it started working for me yesterday. I checked mine and mine's the same. So if you have that problem, just email me. Number one, contact Pearson customer service, because like I say, I set up the course and give it a name, and they generate the course and the number and the sheet, and that's how I give you the sheet. And I add the assignments, but that's literally all I do. Okay, that's literally all I do is do that. And so, contact Pearson customer service because of enough, and let me know. Let me know if you weren't able to get your assignments in. Let me know, okay? Because I'll take care of it. All right. May take me a few days. I'm starting to grade stuff. Okay. May take me a few days, but I'll get caught up. This is week 3. We got 9 more weeks. Okay. This is week 3. We finished the lecture for the module for the exam. Next week, if you weren't here earlier, or if you were sleeping, still a lot of people are here. Still a lot of people are here. Is Mr. Coleman here? Or Miss Coleman, Colimon? Are you here? If you are, either put something in chat or press your space bar and tell me you're here. If you weren't here previously, we're going to have a review from 6 to 6:30. It will not be recorded because I'm not going to put the review up there on your thing and you just go to the review. And we just literally discuss the concept, discuss the answers. Okay. We're not discussing the answer. Well, in some cases, we discuss the answer. The first question is what, and we'll go over, what carries deoxygenated blood to the heart? Well, we learned the superior vena cava, inferior vena cava, and coronary sinus. Okay. That's the 3 vessels. What carries deoxygenated blood away from the heart? The pulmonary trunk, and then later the right and left pulmonary arteries. What carries oxygenated blood back to the heart? Pulmonary veins. What carries oxygenated blood away from the heart? The aorta. Simple question. You would be surprised at the number of people that miss that. And we literally discussed that in the review. So if you weren't in the review or weren't listening, okay, then you didn't get the question. And when you saw it as your first question, you said, I don't know, I'll look through my notes. Oh, the other thing is you really need to have a good working knowledge of your student notes and of the slides so that you can flip through fairly quickly and find the slide you want. Because if you've got 150, 200 slides and you're trying to go through the slides and you got 2 hours to take the exam and you're trying to do that looking for the things that we just mentioned, okay, looking for the things that we just mentioned, so I have a familiarity with the slides. In my computer classes, I took a bunch of computer classes a few years ago. I always printed out the slides and I literally wrote my notes on the slides because that way, because we had an open book open notes, which helped for the not the matching and short answer questions, but then we have a programming question because I was taking the one I remember is I taking programming classes. All right, if you know questions, then we're done for this evening. Okay, I got a Publix Ultimate Sub waiting for me. And young Sheldon will be on at 8 o'clock, so we're in good shape. The lab is the lab. It's 2 of the PhysioX is activity 1, which will show you about blood flow based on radius, and activity 3, which will show you about blood flow based on blood vessel length. Okay, thank you very much, and I will see you. I'll talk to you next week. And somebody got a question?
No, I was just gonna say have a good night, Dr.
Okay,
Phillips.
I appreciate it. We're gonna go.
Thank you.
Our Great Dane is deathly scared of thunderstorms, deathly scared. And last time I looked, the thunderstorms were coming at 4 in the morning. Okay. Hunter Benadryl don't touch her. We had to go to the vet, and she gets Xanax for the thunderstorm. She has a thunderstorm phobia. Okay. And
I hope you guys get through the night.
Yeah, that's all I hope. I hope the thunderstorms hold off to 7. That means I get to sleep. Okay. Because unfortunately, I still wake up early from the old general surgery, plastic surgery days, and the sun comes up and I wake up. But if it can hold off to 7, I would appreciate it. All right. If you have any problems, email me. You have any problems, email me, and just keep working on your thing. The whole goal is to get you an A or B. Next exam, the first exam is going to have 55 points of short answer questions. We're literally going to go over each and every question. We've already went over 2 of them. We're literally going to go over each and every question of the short answer questions during the review. And I'll hit some other high points that I think are important. Okay. Like that blood typing thing, that blood typing worksheet. That, for people that don't know, that was a worksheet for you to fill out. Okay. But since you're a 12-week class, I figured out they wasn't no, you didn't have time to fill it out. I just went ahead and filled it out for you, but I didn't change the name in it. That's why it says worksheet, but there is nothing to fill out. If you look, everything's filled out. So there is nothing to fill out. So that's just for your edification when you're taking the exam, and it's something that you might want to keep later on. All right. Thank you very much. I'll see you next week.